Good morning or good afternoon, depending on where you are. I'm Chris Spinagle from the Warning Decision Training Division. Along with me is Jessica Bunker, also from WDTD, and Alyssa Bates as well. I'd like to welcome you to today's Storm of the Month presentation. Today's presentation comes to you in association with the Research to Operations, Operations to Research Tales team from the National Weather Service in Morehead City, North Carolina. Our presenters are Roger Martin and Zach Chalmers, who will be giving a presentation titled Coupling Mesoanalysis with WoFS. With all that being said, Roger, the floor is yours, so go ahead and take it away.
All right. Hey, everybody. Thanks, Chris. So I'm just going to do a quick kind of 50,000 foot view look at the event synoptically, and then we'll take a look at some of the messaging we did, and then I'll toss it over to Zach, and we'll take a little bit of a deeper dive into WoFS and some of the things we learned from that event. All right. So let's jump right in. So this was WPC's excessive rainfall outlook, their day one outlook, showing a pretty broad slight risk across parts of the Carolinas and the Mid-Atlantic, and then there was a small marginal. For this event in particular, we're going to be focusing on Greenville, North Carolina, which is in the black circle there in eastern North Carolina. So synoptically, we were, this is pretty typical late spring, early summer pattern. The strongest part of the jet was well removed to the north of the region. But we kind of left kind of a weak zonal flow with just some embedded shortwave. So we had a shortwave that was coming through late in the afternoon and the evening hours. And then at the surface, you can see there on the bottom right, that's one of the MPDs that WPC had put out. So this is pretty common too, where we'll get these weak fronts to kind of stall or get hung up east side of the Appalachians. So in this case, we had a surface front stalled around the North Carolina-Virginia border. Delineating or separating, we had cloudy, more stable conditions to the north across Virginia, and then cloud-free and much more unstable conditions across most of North Carolina. Precipitant water values were just over 2 inches. That's pretty common, especially in the summer and early fall for this part of the country. However, coming out of the late spring and the early summer, it's a little bit above CLIMO. It puts us around the 90th percentile for moisture. So synoptically, if we're looking at all the different boxes we would be checking or potentially checking for heavy rain and flash flooding, we've got a wave coming through, some good lift. We've got the sea breeze, which we have throughout the summer. Of course, then we have the surface front as well. Good instability, good moisture. So we're checking a lot of boxes for heavy rainfall. Okay, so let's do a quick overview of the timeline, some of the graphics we did, and see how this event transpired for us. So from the messaging standpoint, a little before 4 o'clock that afternoon, we issued our first short-term graphic for our partners. We were highlighting the potential of heavy rainfall, including the Greenville area. And then it was about maybe an hour or two later, the WoFS, the 22Z run of the WoFS showed an increasing signal for heavy rainfall. And we really used, that signal really helped us to refine our messaging. So then we took that initial graphic we put out, and then we tailored that a little bit more to where we thought the greatest risk of flash flooding would be. Of note, and we'll talk about this a little bit more later, that the 22Z run of the WoFS, the signal we saw there, that signal started to increase around 4 hours before the first report of flash flooding. So that's a success there. And then again, a little bit later, we sent out a new graphic to our partners, just highlighting kind of a refined area of where we thought the heavy rain and flash flooding would be. Jump ahead a couple hours further to the 0Z run of the WoFS. Now that signal was growing even stronger, and that gave us more confidence leading in, both on the messaging side, and then as Zach will talk about here in a little bit on as far as radar, on the radar side and with warning decisions and so on. But then it really wasn't until the event this was an evening into the overnight event. So this was a nighttime event, which carries various challenges from a messaging standpoint and impact standpoint. Our first flash flood warning, which was a base flash flood warning, didn't actually go out till about 9:30 that evening. And then about 25 minutes later is when we upgraded the flash flood warning to considerable using flash flood statement. A couple of things there. One of the things, now we did a presentation a couple of weeks ago, something we found out since then. I talked to Kate, the program lead for the hydro program in the Weather Service. And so we had a conversation over the last couple of weeks, and she actually broke down the way we did the warning for this particular event. So one thing, we learned a few things from the way we did the warning, and one of the things the hydro program is trying to get out, and I wanted to help magnify that message a little bit. So we initially triggered WIA with the flash flood statement. I think everyone's aware of that. But then as we went later into the evening, into the overnight, we issued multiple extensions in time. One of the things that I did not know, and a lot of us in our office did not know, is that each extension in time that has a considerable or higher tag will trigger WIA. So what ended up happening with this particular warning, flash flood warning, is from about 9 p.m. to 4 a.m. we triggered WIA 4 separate times. Now there may be cases where you're like, hey, this is what we want to do. This is okay, but especially being that it's an evening and an overnight event, there may be cases where maybe you'd rather trigger WIA not as many times, especially again being overnight. So one of the best practices that Kate had mentioned, and that I think one of the things we'll talk about in our office as well, is maybe that initial extension in time, do that a little bit longer, so then you're not triggering WIA more times than you would like. So maybe a lot of people in the group, I don't know where everyone stands on that as far as awareness. That was newer for me and for a lot of us in our office. So just something to consider, just an operational note there. Jumping forward then, shortly after 10 o'clock, the reports started coming in, roads flooded, cars stranded, water rescues, and so on. And then we continued to get multiple reports throughout the night. So one of the things, for those not familiar with this area, we have a river that actually runs right through the heart of Greenville called the Greenville Run. Now, it's not a super big river, but it is flashy. It does respond very quickly. You can see the hydro trace there below on the bottom of the slide. So there's that rapid rate of rise when the initial round of rainfall came in. Now, at this event, we had multiple rounds of heavy rainfall, so that eventually pushed the Greenville Run into major flood stage. Now, what's interesting is that put it in a major flood stage between 1 and 2 o'clock in the morning. So like I mentioned earlier, this was a nighttime event. We all know there's challenges with that. On the positive side, typically at nighttime, there's less traffic, there's less people on the roads, so you have less people that are potentially driving into flooded roads. However, because it's nighttime, people can't always see that roads are flooded, especially if barricades haven't been set up yet. So again, we did have some cars stranded, water rescues, even though it was a nighttime event. But the other thing is, since the river itself didn't crest until between 1 and 2 o'clock in the morning, oftentimes, situational awareness of the public starts to decrease. Maybe phones are off. A lot of people have gone to sleep by this time. So, with this event and other similar events, you can have water rising around people's homes and they would have no idea because they're sleeping. So, we were trying to get the message out through Slack. We were trying to, pump information out through social media. But obviously, if someone's sleeping, they're not actively engaged in social media. So that is where one of the positives, I believe, of WIA, and even in this case, sending out WIAs multiple times. So that was a unique challenge with this event. But the other part of that is because of the river. When we get the initial round of heavy rainfall, we get, because of the urbanization of Greenville, we're going to get flash flooding from that. But then the Greenville Run will eventually exacerbate and extend the period of impacts. And that's what happened with this event. And it wasn't until about 6 o'clock that next morning that we finally were able to let the last flash flood warning for Greenville expire. Couple of quick things I wanted to point out about the hydrograph. So one, some of you may be looking at that, and the thing that maybe stands out the most is, okay, what kind of gauges do y'all have there in North Carolina? That seems kind of an odd trace there at the top. So after the fact, we found out that this particular gauge had a cap, and the cap was set at 10 feet. The cap was designed to prevent erroneous data from going out, so that's okay. That makes sense. But we've since changed that and had that adjusted so that the cap is not as low. But in real time, that was a little bit of a challenge because we were trying to update the river flood warnings and we didn't have live data at that point. So we had to make some assumptions. In fact, actually, in the moment, me and one of the other forecasters, we actually thought the gauge had been damaged because the water is rising so fast. And this was becoming a more notable hydro event for us for this area. But the gauge is fine. We were still able to get the crest. So this was the highest, and as of this presentation, still remains the highest crest on record. So that's notable, but also notable because of just the lay of the land here and the topography. Well, we have very little topography, sandy soils and so on. We typically don't see a lot of flash flooding outside of tropical events. So this is interesting because this crest on record is not from a tropical event, because this event was non-tropical. and it bests the previous record, which was tropical, and I believe that was from Ophelia from a couple of years ago. Okay, so let's take a look at a couple of graphics that we put together for our partners. So one of the things we really have been trying to do, the Weather Service is continuing to move forward with probabilistic and scenario messaging, and we wanted to embrace that in this event. We mentioned our partners, the most likely scenario was 3 to 5 inches of rainfall, but then there was a reasonable worst case of 4 to 8 inches or even higher. And then this is around that time, or maybe a couple hours later, this is when the 22Z run of the WoFS, this is when we started seeing that increasing signal for heavy rainfall. Now, when we're looking at this, I think we all know, point probabilities have some value and there's some place for that. But when we're looking at especially probabilistic data, we're trying to look for trends, we're trying to look for general signals. So if you look, the point probability at Greenville is actually relatively low, maybe 20 to 30% of exceeding greater 3 inches of rainfall. But if you look, Greenville was within the larger signal that we were seeing in WoFS at this time. Looking at probability of greater than 5 inches, that signal wasn't as strong right now. But there was a signal there, something that stood out, but it wasn't quite as strong as later runs. And then looking at the 90th percentile of QPF, we notice the potential for heavy rainfall and some amount potentially exceeding 8 inches. So we took the guidance, we took everything from the mesoanalysis side of it, and then we combined that with the 22Z guidance of the WoFS, and then we used that again to refine our messaging and our risk area for our partners where we thought the greatest risk of flash flooding was. One thing I was proud of that our office did was we stayed consistent with the messaging. One thing that's interesting is both the graphic before and the graphic that I'm showing now. All these graphics came 3 to 5 hours before we even started seeing much in the way of heavy rainfall, period. And, see, we've all kind of been there, I'm sure, where you have places where there's a higher end potential with an event, you're messaging that potential, but then, you kind of go 2 or 3 hours in the event and so far it's not happening. And there can be kind of that, are we overhyping this? Are we actually giving our partners something they can use? And I just want to encourage people, I know every event doesn't work out perfect, but part of our job is telling our partners what we know when we know it. And, there's some risk and reward with that, but there's not this binary, it verified, it didn't verified. I think sometimes we have to move away from that so that we can give our partners actionable information. And again, that worked out in this case. Obviously we had flash flooding in Greenville, but up the road in Plymouth, they didn't have flash flooding. So it wasn't like every spot in our outlook area had flash flooding, but just something to consider for future events. Okay, lastly, this is a 0Z run of the WoFS for this event. This is when we really started to see that signal increase. Now the probabilities had jumped up to 80 to 90% plus. You also notice, again, the point probability at Greenville is relatively low. And again, Zach will talk more about that here in just a minute. But one thing that really stood out on the 0Z run was the probability of greater than 5 inches of rainfall increased dramatically. So now instead of 20 to 30, now we're looking at 70 to 80% or higher for those higher end amounts. And consequently, too, the 90th percentile of QPF also went up. So now we're looking at potential for 8 to 10 inches on the high side. All right, so what happened with this event? Well, I'm going to toss it to Zach, and he's got some information on that and some. I'm excited about some of what he's going to show kind of on the meso side and how we were able to use that. So, Zach.
All right, thanks, Roger. Yeah, so as Roger mentioned, we just kind of wanted to take a step through now of some of the verification from the event itself and kind of compare that to some of the signals that we were seeing within the WoFS runs and how that kind of impacted not only some of our kind of decisions and messaging during the event, but how we incorporated that into the conceptual model that we were building kind of throughout the event as to how it was going to unfold. So starting off here, we've got this GIF from from the WoFS viewer that shows the MRMS QPE from kind of after the event, looking over a 6-hour window. And I'll let the GIF kind of keep playing on the right, but I'll put a zoomed in view down on the bottom left from the last frame to kind of really focus in on some of the areas that we're interested in here. So what we've got plotted is the green boxes represent the flash flood warnings. It only shows the 3-hour window for the initial flash flood warning. So we're kind of missing the one over the Greenville area there, but it was still in effect at this time and just doesn't quite show up in the data plotter there. And then we've got the flash flood LSRs from across the region plotted in the purple diamonds. So then looking at the shading, we can really see that this kind of got two kind of main corridors of heavy rainfall that we were really focused on. So the first is across our northwestern counties within our CWA, and that's where we really saw these totals of anywhere from about 4 to 7 inches or so, mainly in and around that Greenville area. Getting a little bit further north and east in North Carolina, so far northeastern NC, this gets up into Wakefield's area, north of a body of water there known as the Albemarle Sound. And this is where we saw some lower end totals, but kind of a secondary maximum in some of the QP or rainfall totals, ranging from about 2 to 3, maybe 2 to 4 inches or so. And if we take a look then at the 22 UTC run, this is the QPF, 90th percentile QPF from the WoFS 22 UTC run. Same thing, GIF on the right there with the flash flood warnings and LSRs plotted, and then I'll put the kind of still image from the final frame in the bottom left there. One of the things that we can note, this is something that Roger showed earlier, is that we've kind of got the same 2 areas that are being forecast within the WoFS system itself, where we're going to see some of those heavy rainfall amounts. So the first is a little bit south and west of our Greenville area. Similar totals, about 4 to 7 inches being forecast within the WoFS 90th percentile accumulations there. And then we've got kind of the separate kind of maximum a little bit further south of the Albemarle Sound, kind of northeastern NC. And that's where we've got some totals within WoFS that are kind of up in that 5 to maybe 10 inch range, with even kind of that maximum there in that 7 to 10 inch range. And as Roger mentioned, in the 22 UTC run, this is where we were kind of seeing some of those higher end probabilities of 3 or 5 plus inches being possible, especially across that vicinity in northeastern NC. Jumping on then to the 0 UTC run, as Roger mentioned earlier, this is where we really saw an uptick in those probabilities near the Greenville area, especially the probabilities of seeing more than 5 inches of accumulated rain. And similarly, looking at kind of what was forecast within the WoFS system here, we actually saw the system kind of decrease the probabilities and the amounts of rainfall that it was forecasting kind of within the northeastern NC vicinity near the Albemarle Sound. But at the same time, as I just mentioned, we saw that increase in 5 plus inch probabilities just kind of south and west of Greenville. We can actually see within the WoFS viewer here, far bottom right, that max value gets up to about 9.5 inches, just south and west of where Greenville was. And we can kind of note that that kind of axis of heavy rainfall within WoFS, the northern gradient is kind of where we start to see those flash flood reports and kind of flash flood warnings being. And so when we take a look at kind of all 3 of these put together here, so we've got verification on the right from MRMS, and then the 22 and 0 UTC runs on the left. We can kind of note that the WoFS runs were generally predicting those axes of heavy rainfall to be just a little bit further south compared to where they were within verification. So just kind of comparing it to, once again, those flash flood warnings and the LSR reports there themselves. Typically, the kind of gradients and heavy rainfall within WoFS were just on the kind of the southern edge of where some of those LSRs and flash flood warnings were being issued. So we wanted to kind of step in and then take a look at the COCO-ROS reports that we got from the event to compare this to what we saw with MRMS to make sure that it was giving us a good representation of how the event unfolded. And so taking kind of the broad look here at the COCO-ROS viewer, we can kind of see that there's a main corridor of 4 to 5 inch accumulations across the Greenville area and Pitt County, and then kind of extending up into portions of Raleigh's CWA, and then a separate area of about 2 to 3.5 inches present across northeastern NC. And then taking a rough approximation of where some of those forecast heavy rainfall axes were from WoFS, especially from the 0 UTC run, plotting them in the green ellipses there, we can kind of see that they were just still that little bit further south, maybe on the order of a few tens of miles south of where we saw some of those heavier rainfall totals set up. Taking the zoomed in look then, kind of looking across Greenville and Pitt County, we've got this main corridor here, and now we can really see that we're exceeding those 5 inch accumulations. So looking more so now with max totals on the order of 5 to 7 inches or so across Greenville. Now, it's pretty similar to what WoFS was showing with the 90th percentile forecast accumulations. We could have easily seen a higher end total that's maybe just missed by the slight coarseness of our network here across this. So very possible that we saw one of those totals get up to 8, maybe 9, could be even up to 10 inches, but maybe just missed by our COCO-ROS gauges there. Looking south of this, though, looking at the region that WoFS was forecasting these heavier rainfall totals to set up, we really see totals only ranging from not even getting any rain, so 0 inches, up to only about ½ inch or so of accumulations. And so similarly, just kind of as MRMS showed, the WoFS forecasts were also on kind of the southern gradient of where that heavy rainfall set up in the real event. Moving across to kind of northeastern NC then, we see kind of the same signal where we had this persistent corridor of high WoFS probabilities greater than 70% or so, 3+ inches, that we noted were several runs of WoFS kind of south of the Albemarle Sound vicinity near kind of the Highway 64 corridor. It was really north of the Albemarle Sound that we saw a slightly heavier corridor of rain set up with totals ranging from about 2 to 3.5 inches or so. And then south along that Highway 64 corridor, we really only saw about 1 to 2 inches. And that was something that we kind of noted as the event unfolded, where we had our kind of conceptual model of the event built, and then the WAFS runs were kind of highlighting this area for 3 or 5 plus inch accumulations for kind of several runs. And it kind of kept getting delayed within the system. It kept getting pushed back hour by hour. And it was something that we kind of noticed. And actually, even though we had kind of messaged this area, the further we got in the event, the kind of more that we were kind of holding off a little bit, kind of noting that some of that rainfall was setting up a little bit further to the north compared to where WAFS was indicating it would. So taking the step back to MRMS then, and just kind of showing that this gives us a good representation for the comparisons that we did earlier compared to what Kokoraj showed. We've kind of got those pinks and reds colors set up kind of center left near the Greenville area that show that we still had those 5 to 7 inch accumulations, very similar to what Kokoraj showed. So this is giving us pretty good representation that matches some of what our gauge observation showed. Similarly, across northeastern NC, kind of those yellows and golds, so 2 to 3, maybe 2 to 4 inches showing up in MRMS, very similar to the totals that we saw within the gauges there, about 2 to 3.5 inches. And then same thing, showing the approximate locations of the WAFS forecast heavy rainfall axes. We can really just kind of see that those are a little bit further south from where they set up in the real event. Maybe getting anywhere from like 1/2 inch to 1 inch across northeastern NC, where WAFS was forecasting 3 to 5 inches. And then a little bit further south and west near Greenville, that area kind of setting up along the southern edge of the heavy rainfall gradient, maybe only seeing about a trace of rain or so. So kind of during the events, when we were working this, one of the things that we were trying to do was really couple mesoanalysis with what WAFS was showing to really build our kind of conceptual model for how the event was going to unfold. And this was really important for us because we kind of had our anticipation of the potential for flash flooding, but then WAFS was helping us refine kind of our expectation for the high-end rainfall totals and where they could potentially set up. So for example, WAFS was kind of giving us a lot of indication that we might see 3 or 5 plus inch rainfall totals, maybe as high as 8 or 9 inches across parts of the area. But we were kind of noting, as I mentioned a minute ago, that some of the kind of rainfall positionings within WAFS were maybe not exactly how it was setting up throughout the event, especially as we got closer to the time where the rain kind of started within Greenville itself. So afterwards, we kind of wanted to take a look back and really kind of compare what we were seeing during the event to what we were seeing within WAFS, and maybe kind of see why some of these subtle southward biases were setting up within some of the rainfall forecasts. The big thing that stood out to us was taking a look at some of the kind of positioning within WAFS of not only the boundaries, but also of the forecast storms themselves that are affecting that kind of rainfall total of forecast. So on the right here, we have a GIF from the 22 UTC WAFS run where the shading in the kind of yellows, oranges, and reds shows mean boundary layer moisture convergence. The black plots then show in the contours the WAFS probability match mean reflectivity, with the black blobs then showing the MRMS observed 40 plus dBc reflectivity. And one of the things that we noted was that, especially early on in the runs, they match up fairly well. But as you get kind of an hour or two into the WAFS runs, the boundaries kind of shown by that mean boundary layer moisture convergence are being shoved just a little bit further south of where they set up in real life. And along with that, the WAFS kind of thunderstorm positions, or the reflectivity shown by the contours there, is also getting nudged just a little bit further south than where it ends up verifying via the MRMS blobs. And so this is kind of a consistent thing within not only the 22 UTC run, but even within the 0 UTC run, only an hour or two ahead of where the kind of heavy rainfall really set up in Greenville. And so it's something that we kind of started to notice during the events, and then we picked up on a lot more later once we looked back at kind of some of the WAFS runs and the verification, where that boundary was just getting shoved a little bit too far south. It could have been due to something maybe like there was subtly too much dry air within the low levels within the WAFS system, and so maybe there was a little bit more evaporative cooling that nudged the boundary a little bit further south, or maybe it's something else. It's not really something we've had too much time to dig into, but we kind of noticed the signal within the boundary layer moisture convergence as being a potential explanation for why that boundary and why some of those rainfall totals within the forecast were nudged just a little bit further south. So ultimately, kind of wrapping this up and just kind of highlighting the main takeaways that we had from the events and that we really wanted to kind of convey through the presentation. Kind of despite some of these kind of location biases that we talked about, WAFS really offered a lot of useful guidance to us during the events, really helping us forecasters anticipate some of these significant rainfall accumulations of 5+ inches, maybe even up to 7 to 8 inches were being possible across the area. Having worked the event myself and looked at a lot of the WAFS runs, one of the things that also helped us with was that, as Roger mentioned earlier, we actually don't have a ton of easy flash flooding in our area. A lot of it's related to tropical events because our soils are very sandy, so they don't flood very easily in a lot of cases. So oftentimes we kind of have to wait a little bit longer to issue some of these flash flood warnings to really kind of see how the soils are going to drain the water, or how maybe some of the kind of urban areas are going to accumulate some of that water. And so one of the things we did during this event was we were actually a little bit more proactive with the issuance of the flash flood warning for the Greenville area than we might typically be. We kind of saw maybe about an inch or so, maybe an inch and a half of rain starting to accumulate in Greenville. And knowing that some of those higher end totals were possible and kind of seeing the trends within radar and within the WoFS probabilities kind of nudged us to be a little bit more proactive with that warning. And as Roger showed, we ended up having about a 45 minute lead time for that flash flood warning compared to when our first LSR came in for the Greenville area. As we noted then, even though the kind of axes of greatest 3+ inch rainfall were biased a little bit further south within WoFS compared to the observed locations, we still were kind of looking at what the kind of probabilities in the general areas around some of these locations were. And so we kind of noted that WoFS was maybe a little bit too far south, showed a little bit of that southward bias, potentially being due to it being a little too progressive with the boundaries. But we still had kind of some of these trends in the probabilities kind of surrounding some of the regions that we were paying attention to that kind of helped us kind of see what the signal for some of this rainfall was. And ultimately what this does is it really highlighted, especially to us, the importance of skillful mesoanalysis and coupling it with some of this new guidance like WoFS to help determine potential impacts, even if that placement is slightly off. And so as I mentioned, we were kind of going into the event with our conceptual model of how it was going to unfold. And then we were using the WoFS runs and the information from them to kind of adjust that model. So whether that was getting a better appreciation of maybe what some of the higher end potential for flash flooding was, or where some of the placements were, even if it was a little bit off of where it ended up verifying, it still helped us kind of refine that understanding of how the event was unfolding and what the potential impacts may be. And so despite some of those subtle location biases, WoFS really helped us kind of narrow down and message that heavy rain and flash flooding risk for local partners and for the public as well. We produced a couple of those graphics that Roger showed off earlier and really kind of honed in on the messaging throughout multiple hours kind of leading up to the event. And it even helped give us a little bit of an extra nudge towards issuing some of those flash flood warnings as the event verified. And so overall, we really enjoyed and liked being able to incorporate it into our workflow for this event. And it's something that we're really looking forward to working with more in the future, as it definitely offered a lot of useful guidance to us during this event itself. And so with that, we'll just kind of leave there and say thank you for tuning in to listen. We're happy to take some questions now in the Q&A session. And then if anything pops up later, both of our emails are on the screen there. And so feel free to shoot either Roger or I an email, and we're happy to take any questions. So thank you very much.
Thanks, Roger and Zach, for that great presentation. I'm Elisa Bates with Zero, and I'm WDTD's R2O liaison. Therefore, I'm here to let you all know that unfortunately, WoFS is still an experimental product suite. It is not operational. Currently, WoFS is being run by NWS Offices of Science and Technology Integration, or OSTI, in a demonstrational capacity. That means it's being offered temporarily and only when certain criteria are met and for limited domains. For more information, you can check out cbwofs.vlab.noaa.gov and the NWS OSTI WoFS Conversation Google chat room.
Thanks. We'd just like to thank Roger and Zach for today's presentation. As always, we are looking for presenters. Please reach out to myself or Jessica Bunker if you're interested in presenting. Thank you all for attending. Our next Storm of the Month presentation will take place a week earlier than normal. It'll be December 16th. Charlie Woodrum will give a presentation titled Surveying the Architects, Lessons Learned. So we hope you can join us then, and we hope you have a great rest of your day. Thanks for your attendance.